We're going to continue to talk about systems of linear equations and solving them, but now we're going to do it with a different method, maybe something that might be new to you, called a matrix, or matrices, which is the plural. So you might think to yourself, what is a matrix? Well, in math, a matrix just is a rectangular array of numbers. Yeah? An array is like a list, except since it's like rectangular, it's going to have two dimensions. Not just one long dimension. It's going to have columns and rows. Kind of like a table, really. But it's just a rectangular array of numbers, and it's used for many mathematical purposes. And it represents things like vectors, which is something that you'll learn about in calculus, or numbers that go with things. We're going to use them specifically to represent or to lay out all the coefficients of a system of equations. Okay? So for us, we're actually going to be working with something specific, a specific kind of matrix, which is called an augmented matrix. So it's used to represent a system of equations. So let's just look at an example of a system of equations. We'll just look at a 2 by 2 system. X plus 4y equals 14, and 3x minus 2y equals 0. Notice that both of these equations are in what we would call standard form. The x terms are first, the y terms are second, then there's an equals, and then there's a constant term. Okay? So with a system like this in standard form, we can write it, so these two things are the same, as what we call an augmented matrix, where all we do is list the coefficients of each of the terms. And we draw a little line here to kind of show where the equals is, right? And we just assume that the first column, right? These are the coefficients of the x's. The second column are the coefficients of the y's, okay? And the third one are constants. Okay, so we have to have them in that form so that, that can be true. Okay, now each matrix has rows, so we'll call this row 1 and this row 2, and it also has columns. So the first column, the 1 and the 3, are in column 1. 4 and negative 2 are in column 2, and the 1 and the 0 are in column 3. Okay, so it has rows and it has columns. Okay, so to solve a system of equations using a matrix, we can actually just use the coefficients, and we can use what we call row operations. Right? And so they are what they say. They are operations that we do on the rows. Right, so here's the rows that I'm circling of the matrix. Yeah, and they're the exact same things that we did to the equations when we were doing elimination in section 11.1, right? Because each row represents an equation, right? So here are the row operations. These are the things that you can do in a matrix that will help us solve, okay? You can interchange any two rows. Right? You can replace a row by a non-zero multiple of that row. And you can replace a row by a sum of that row and a constant non-zero multiple of another row. Right? So these 3 row operations are analogous to the things that we did when we were eliminating. Okay? All right. Now, your book likes to describe row operations like this, and I don't love it, but I'm going to show you how, because there are problems that you have to do in your homework like this. We're going to apply, it will tell you to apply And then here's how they're going to describe the row operation. They're going to say R2, which R2 stands for the new row 2 that you're going to create when you do the operation. And the way you're going to create it is you're going to take -3 times little r1. Little r1 is the old or original row 1, and add it to little r2, which is the old row 2. Okay, so we're going to apply that to the matrix 1, 3, -2, -5, 2, 9. Okay, all right. So this is R1 and this is R2, right? But we're going to apply this row operation to create a new row 2. Okay, all right. So we're going to take, it's telling us take -3 times row 1. So -3 times row 1. 1, -2, 2. So what I'm kind of doing here is like making a, kind of an adjusted matrix here, right? And when I do that, I get -3, +6, and -6, okay? And then it says, take that and add it to row 2, okay? So if we add, and all we're doing is adding the coefficients, +3, -5, 9, so we get 0, right? 1, and 3. And this becomes, that's equal to our big R2, that's our new row 2, right? So then we have a new matrix that it has the original same row 1, because our row operation isn't replacing row 2. I'm sorry, it isn't replacing row 1, it's replacing row 2. Okay, so we keep the same row 1, but now our row 2 is going to be 0, 1, 3, R2. Does that make sense? So there are a couple of questions where you just have to practice, using some row operations. And what we're really going to do is apply those row operations to solving a system of equations. Okay, so now what I'm going to do is solve a system of equations for you, and we're going to have to come up with our own row operations to make it work. Okay, so here's an example. We're going to solve the system x minus y plus 3z equals 4, x plus 2y minus 2z equals 10, and 3x minus y plus 5z equals 14 using a matrix. Okay, now, so the first thing we're going to do is we're going to create the augmented matrix for this system. So what that means to do is just take all the coefficients and put them in this array, this rectangle. So 1, -1, 3, 4 for the first equation, 1, 2, -2, 10 for the second equation, and 3, -1, 5, 14. Okay, now I'm going to ruin something. I'm going to tell you what the solutions are, what the solution is, what x is, what y is, and what z is, so that we know what we're headed for, okay, for this particular problem. And I want to show you what that looks like in a matrix. So our goal, right, this is our goal, is to change this, the current augmented matrix that we just wrote into an augmented matrix that looks like this. Oops. Kitty. Come on. Okay. Notice what this matrix has. It has a 1 in the diagonal, zeros everywhere else left of the line, and then 2, 7, 3. This is called a reduced row, R-O-W, echelon form. Make that a better W. Okay? So our goal is to get our matrix into reduced row echelon form. Why would we want to do that? Well, remember that the 1 up here in the upper left corner, it stands for the coefficient of x, right? So what this says then across this row, this top row, is that 1x plus 0y plus 0z equals 2. So 1x plus 0y plus 0z equals 2. Well, if we simplify that, we get x equals 2, right? So the value in the upper right-hand corner is the value of x, or whatever our first variable is. Now, for the second, that says that 0x plus 1y plus 0z equals 7. Well, simplifying that gives us y equals 7, right? So the second value is the y. So this is x, this is y. And similarly, for the same reason, 3 is z. Okay. Now that we know what we're headed for, let's do it. So we've got our original augmented matrix. The first thing we're going to do is we're going to make these two numbers zeros. We're going to make them into 0. Okay? Now, how do we do that? Well, if I multiply, so I'm going to say this little arrow is representing the row operation. We're going to multiply row 2 by -1 and add to row 1, right? That will give us a 0 there, okay? Now, when we work with matrices, we actually don't ever write out the interim steps. We just kind of do it in our heads, okay? So, I'm taking I'm taking row 2 and multiplying by -1. So if I take 1 times -1 plus 1 will give me 0. And then I take 2 times -1, which is -2, plus a -1 gives me a -3. So notice I'm replacing row 2, okay? Then -2 times -1 is 1, plus 3, is 2, plus 3 is 5, yeah? And then 10 times -1 is -10, plus 4 is -6, okay? And I'm going to do another thing at the same time for row 3. I'm going to multiply row 1 this time. Doesn't matter, I could have used 2. By -3 and add to row 3. And that's going to give me my new row 3, right? So now we've got row 1. So let's take 1 here times -3. That's -3. -3 plus -3 is 0. -1 times -1, times -3 is +3, plus a -1 is 2. 3 times -3 is -9, plus 5 is -4. And 4 times -3 is -6, plus 14. 4 times -3 is -12 plus 14, which is 2. And we're not doing anything to the first row. I'm just going to copy it. Okay, so we got 2 zeros there. Now the next thing we're going to do, the next goal, right, is we want to make the -3, make this a 1. Make this a 1. Okay, so let's look back at our goal. Remember, there's 1s along the diagonals, along the diagonal here, and the rest are zeros, except for past the line. Okay, so I've got 2 zeros already of the zeros. I've got a 1 in the upper left-hand corner. Now I need to make the -3 into a 1. Well, there's something I could multiply the entire row by to get a 1 there, and that would be -1/3, the reciprocal. So that's what I'm going to do with this arrow. I'm going to multiply row 2 by -1/3. Okay? Now all the other rows are going to stay the same, and I like to rewrite the rows that I'm not changing first, most of the time. Okay? So 0 times -1/3 is still 0. -3 times -1/3 is 1, and that's why we wanted to do that. We got it. Then 5 times -1/3 is -5/3, and -6 times -1/3 is 2. Alright? What are we going to do next? Well, let's try to get a 0 here for the 2. Okay? What can we do to get a 0? How about multiply row 2 by -2 and add to row 3, right? And that'll give us a 0. My time's running out, so the next video I will continue right from here.